we are at 2 o'clock here on March 12th, 2024. And this is the Mars Society Ambassador Briefing. I'm James Melton, Chief Ambassador of the Mars Society, and we have a good program for you going today. Our mission statement, by the way, is to serve as a professional team of people dedicated to elevating public awareness of our mission to land humans on Mars in this decade and begin settling the red planet, which, by the way, is becoming increasingly close. And Bill Carton will share some of that with you very shortly. Let me bring in John Ratliff from Austin, Texas. There he is. Okay, so Bill Carton, let me just talk briefly about Bill. And he's going to share some slides. And Bill has been out there speaking on a regular basis to a variety of audiences, from pubs to science museums, presenting programs on his own for many purposes. And he is one of our ambassadors that's come on board and has been here for quite a while, and always has good things to share. So I had asked Bill, because of his knowledge of SpaceX and what they're doing with the Starship, to give us a little brief rundown, being as how we have a very special liftoff coming up on Thursday morning, and Bill will share all of that with you. And then after that, we're going to get into the rest of the agenda. Bob Solheim is one of our newest ambassadors, the gentleman in the red. And we're going to talk with Ron Story about the Star Trek convention in San Francisco. Torsten Eschweiler is going to be giving us a bit of information on how he landed the job to speak to the Analog Astronaut convention coming up near Biosphere 2. I'm not sure of the date of that, but he can fill that in for us. But right now, it's going to be Bill Carton. Bill, take it away and take what time you need to give us some updates with your normal, inimitable style.
Oh, thank you. Thank you. Okay. I just started using new video switching stuff. So let me share. Okay. I think I'm back to good preview. All right. So over 10 years ago, just after SpaceX had their #1 flight that blew up, Falcon 1 in Kwajalein, I said, oh, these guys are new. They're underdogs. Maybe I should root for the underdogs. And flight 2 and 3 both failed, but they were easy to fix. Just timing at stage separation. In any event, so my background is semiconductor test equipment, but I've been a rocket fan forever. I used to get NASA social media credentials. I was pretty much the oldest social media person because I started the SpaceX fan group on Facebook. It's not the largest, but it's the best curated. Since I've semi-retired, now I'm in Oregon, where I was in the 90s. So I'm a docent at Evergreen Air and Space Museum. So anybody gets to Oregon, I can get you in for free, give you private behind-the-scenes tour, and so forth. Heavy lift vehicles, you should all know something about this, but because James is recording it, other people will see it hopefully in the future. Now, of course, thrust is not proportional to height, but the Starship was designed with twice the thrust of Saturn V. It can't put as much into orbit because it doesn't have hydrogen locks, third stage, second and third stage. But the entire Starship, the top 40%, is fully reusable, which changes the economics massively. Starship original renders from them showed this massive window arrangement, probably won't happen, but the idea is similar. So this is an early stacking version uh, of the Starship and booster. Heat tiles on the half of the Starship that goes to orbit. We'll look at those closer up later. But in terms of height versus SLS, Saturn V, and Starship, Starship will launch with 10 million pounds of propellant, which is more than the Saturn V had um, for thrust. SLS is pretty weak by comparison. It can put things in lunar orbit, but it can't put astronauts plus a lander. So of course, there's a human landing system contracts that went to SpaceX and Blue Origin. Talk about that in a little bit. But the way SpaceX designed it, this was originally designed for the Mars mission. This is not a PowerPoint rocket. I've been frustrated for 50 years, like you, with PowerPoint rockets that never get funded, never have administration backing, never have congressional backing, and never come to pass. So Elon's vision is to make us a multiplanetary species. So the Starship architecture was originally meant for the Mars mission. It's also going to be useful for Moon and low Earth orbit. But the way it optimized out, there's 31 engines on the first stage, and they are optimized for thrust, optimized for many other things, not just thrust, not just size, but for cost, ease of manufacture, ease of transport, ease of testing, ease of separating them with titanium blast shields so that if the computer doesn't shut one down fast enough and the turbo pump overspeeds or the combustion chamber fails, then it should not take out its neighbors. And with redundancy, you can lose one or two engines and burn the others longer and still get to orbit. But it is a massively impressive underbody look. The booster has grid fins just like Falcon 9s, except they do the math all the time. Engineers come up with ideas and say, hey, why don't we do it this way? In the case of grid fins, they did the math and they concluded that leaving them out in the wind and not retracting them costs less in friction penalty than it does for the mass of the retraction mechanism. So Elon says, one of Elon's famous phrases is, the best part is no part. If you can, design it out. So they've designed out pneumatic pusher springs now between the first and second stage. They're using a concept called hot staging, which everybody should be familiar with from Titan days. You start the second stage engine before they separate, then you don't need ullage motors and there's no coasting. And actually, they did the math. They get 2 or 3% more mass to orbit by using hot staging. Risky process, but at least on flight test 2, that part didn't fail. Hot staging worked. Other things failed, but hot staging worked first time. We're amazed. Absolutely amazed. One thing that people always ask about, the heat tiles are black. Aren't they as fragile as the space shuttle tiles? No, because they're modern technology, 30-year, 40-year better technology, much more robust. You can't put your finger through them, and they're attached mechanically and not using glue, which was an issue ages ago. Glue's just a bad idea. So these clip-on, now it turns out 3 clips aren't enough. So they're for next generation, they're reducing size of the tiles, perhaps increasing number of clips. But that is the way they're held on. They're, instead of 50,000 different size tiles, all serial numbered, there's only about 6 different size tiles, and 90% are the same hexagonal size. So what is Starship good for? Well, number one thing is to get the next generation Starlinks to orbit. Starlinks throw off enough profit. That's part of the way Elon is funding the Mars mission. We're not sure who will supply payloads, might be NASA, might be multinational corporations, might be affinity groups, might be small nations. But in any event, Starlink throws off enough profit that should be a big contributor to funding the rest of Starship. Starship's already cost over $5 billion. And you'll see from the manufacturing site where it's been spent. But Starlink is just revolutionizing internet in remote areas. Artemis, now SpaceX got small amounts of money to help develop and demonstrate technologies you need to do the human landing system part of Artemis. A lot of people mock Starship for being too big, too tall, too tippy. We think that they can solve those problems. And of course, Mars. The whole concept of Starship from day one, from the first time Elon presented it in Guadalajara, Mexico, it's sized and architected for Mars using in situ resource utilization to make methane to get home. So you can carry more to Mars if you don't have to carry your return propellant. So the first few things that get sent to Mars should be robotic propellant factories. Now, where are they launching from? This is now Boca Chica. Boca Chica is actually about the same latitude as Key West. So it's got the advantage of being close to the equator like Florida. It has the great advantage of not being surrounded by an Air Force base and Air Force oversight, Space Force now oversight. And they're doing a lot of environmental mitigation to make sure they don't kill turtles and so forth. There are protesters, there are issues, but Boca Chica is right next to Brownsville, which is right next to Spring Break Central down there of the island. Anyway, there's 4 major Boca Chica sites. Now, each of these sites gets overflights from a supported crew, so a Patreon supported crew and YouTube contributions, Rio Grande Valley aerial photography, RGV aerial photography. They have a weekly, very nicely edited video on YouTube, which it takes like 2 or 3 hours a week to keep up with all the video. It's hard, but this is just a summary of what's out there. But there's 4 main sites down there: the launch site near the water, build site further inland, and then they picked up 2 more sites called Sanchez and Massey's. I think I'm not sure which one, Sanchez or Massey's, used to be a shooting range. In the videos, they have many, it's crowdsourced image analysis. So they have many people on Reddit and YouTube who try to identify the activities going on, the buildings, they can keep track of the serial numbers. There's a group called the Ring Watchers that keep track of the serial numbers down there. Massey site is mostly for proof testing of a built booster or Starship. So they put it on test stands, fill it full of liquid nitrogen, and pressure test it. And if that passes, they're building flame trenches down there to do static fires. Sanchez site is more the same, but also it's a ring yard where they build new rings and they build new transport trucks. The build site, they have 3 major buildings now, which are like mini VABs. They don't build the Starship on top of a booster. They don't stack it at the build site. They build the boosters and separately build Starships, and then truck them to the launch site where a launch tower integrates them out in the open. Star Factory is huge. I believe there's now 4,000 or 5,000 people working at this site. So that they're also building a multi-story parking garage and so forth. There is some, you can see in the lower right corner, there's some trailers and little buildings that there's some on-site residences, but that's not for production workers so much as managers. The launch site is right near the tip of all their leased sites, and it's closest to the ocean. So right now there's a launch stand, tower, which Elon calls stage 0. And that has at least as much complexity as stage 1 of a regular rocket. Um, then the booster is all stainless steel, Starship on top, two lifting arms we call chopsticks, which are used for integration, also for um, in the future, when they can perfect hover and translation, they'll bring boosters and starships um, back to hover and get caught by the chopsticks, and that saves the weight, the mass of legs on those units. So they're not doing testing, including legs anymore. IFT-3, if it goes off as planned this week, we'll just plunk the booster in the ocean, hopefully slowly. The Starship isn't planned for a hover test and a rotation like earlier serial numbers were tested. Also, at the launch site, there's a lot of vertical tanks for water, liquid nitrogen, liquid oxygen. There's a lot of horizontal tanks for the same. The horizontal tanks are ones that can be sent through the pre-chillers, because just like Falcon 9 is using pre-chilled, densified LOX and RP1, the Starship is using densified methane and LOX, well below their boiling temperature. Because of that, there's less boil off and less venting. And the one thing they added between test flight 1 and 2 was a water deluge plate underneath, like an upside down shower. And that's fed by water tanks. Water tanks here, and beyond them, some 5,000 psi nitrogen cylinders. So that gets pumped out at high pressure. They didn't have enough stable ground to build a tall water tank to get gravity fed pressure. So they use nitrogen. Way over here on the left is old Hoppy, the first hopper that was sent up on one Raptor, which destroyed itself in flight. But Hoppy survived. Now they plunk cameras on top of it, and weather station anemometers and so forth. Here's a closer up of the launch site showing the tankage. All these things you can find on YouTube in the RGV aerial photography videos. Here's how close it is. This is telephoto lens, of course, but here's how close it is to South Padre Island. And, this spring break right about now. So there's all kinds of bikini college kids down there. And they're going to be pretty excited when this goes off. Now, there's also dozens of Texas tank watchers, they call themselves, with video cameras. There's NASA Space Flight has one, Starbase, Lab Padre has some, and they're as long as SpaceX doesn't build up the walls too high, then we can spy on them pretty much all the time, do flyovers and catch them when they close the road, and move a booster down the road, get close-ups of all the goodies, just all the goodies. Here's a slide about the weekly flyovers. It's worth supporting them if you can by Patreon or YouTube. Test flights, you should all be aware of these things anyway, but IFT-1 is April 20th. Stage separation failed. It stayed locked together. That was bad. It went into a tumble. Flight termination system was either too weak or too late, and it didn't do a good job blowing it up until 40 seconds after it should have gone off. Numerous booster engines failed on ascent. That was mostly because the concrete underneath blew up. Instead of obeying the math, it said it should have been okay. They said, oops. rebuilt the whole thing, put in the upside down shower nozzle for a water deluge system from below, and they had that before IFT2, November 18th. Oh, sorry, backwards. Okay. So IFT2, for the first time, and this is what Elon will throw away hardware, throw away millions of dollars of fabricated stuff if somebody comes up with a better idea. Some engineer or maybe Elon came up with the idea and engineers did the math. They said, hot staging will give us 2 or 3% more mass to orbit. That's huge, absolutely huge. They made it work with just one extra 6-foot ring with holes in the side and a bunch of armor on the top of the booster, and hot staging worked. Then you save ullage, you save the delay of staging, separation, and then starting up the second stage, because every second you lose on ascent costs you 32 feet per second. So you want to save that delta V if you can. Booster was destroyed after the flip because a bunch of plumbing was unported and turbo pumps oversped. That was bad. There was another issue of debris getting into the plumbing. That should never have happened. There's probably a lot of root cause analysis going on. Starship almost made it to suborbital. It worked for a long time until they vented some O2 that they took along too much LOX for some ballast to get to orbit. They didn't fill it full of water or iron scrap or something like other test flight companies do, but almost made it to orbit. And then they vented O2 and it blew up in the engine compartment. So they solved and fixed that. FAA said, they went through and found 17 changes, but really SpaceX probably made 500 or 1,000 changes, because this is, the haters just say Elon blew up another one. You've got to defend that and say test flights are supposed to blow up. You learn more from an explosion than you do from a success, because you know where your margins are better. So anyway, IFT3 is the one that might happen Thursday morning. Good luck. Hope the FAA and everybody has their ducks in a row. And I'd be there myself, except I just had minor back surgery. And the doctor said, you're going to spend 3 days in a car driving from Oregon? No, 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 no. So I'm not there. What they hope to do is get some money from NASA for propellant transfer test. They're going to test a Starlink satellite Pez dispenser door opening on the side of it. And they're going to try for the first time a zero-G Raptor relight. There's always this kind of infographic out there from what they intend to do, and they intend to hover the booster back somewhere over the ocean and let it plunk in. And then the Starship, besides doing the orbital, it'll be in a suborbital trajectory that should bring it down near Hawaii. If the Raptor doesn't relight. If the Raptor relights, it should plunk down in the Indian Ocean. For at least the first one, they're not going to try for a soft landing. They hope it explodes and all the debris sinks, because the last thing they need is this propellant tank sitting out there as a hazard to navigation, a hazard to boats, or an attractive nuisance for people to go up and pick up parts and sell them on eBay. I've got videos. I think I should stop here. You can find these videos. There's one put out by SpaceX called Life at Starbase. Fascinating, real video. It goes by fast. You have to go through it frame by frame if you're trying to understand all the issues. And I'll skip through that. There's another one that just showed up a few days ago called IFT3 animation. It's all CGI, but it goes through the process in a better way than SpaceX does at this point. So I highly recommend going to YouTube, learning more about it, especially if you're caught in traffic trying to get to Boca Chica, or if a delay by a day or two. You'll have a bunch of time, and I'm jealous of anybody who gets to go there, but there's a lot of stuff on YouTube you can watch while waiting. So, okay, James, how's that?
It sounds good. I can't imagine why I selected you to make this overview.
Oh, well, I've
I
and
don't
I
know.
I've
I
and
don't
I've
know who else has that expertise. Let's get a vision of you and there you go.
yeah, and I've got my my Starship creme brulee uh
Oh, there
thing.
you go. Oh
So
my
this is a
goodness.
pretty good.
Oh,
This is they sold these to employees only, but I have employee friends.
Yeah.
But it burns butane, but it's a great simulation of a methane blue flame.
Well, that's beautiful. Bill, it's very enlightening, a lot of detail, which of course you have comprehended very well and delivered. Questions for Bill from the audience here, from our ambassadors.
Oh,
yeah, Bill,
please.
this is John Ratliff here. Just one quick comment. You mentioned 31 engines in the Super Heavy. I think it's actually 33, but just
Oh,
a minor note.
yes. Yes. Thank you. Thank you. Yeah. Outer ring, two inner rings.
Yes, I guess in one of the first launches, three of the 33 actually did not function well, so they did go with 31. But
Oh
uh,
yeah, but then more failed on ascent. I think by the time they got the stage separation, they'd lost seven.
was
Some
it
of them, some
okay?
of them went through what we call engine-rich exhaust.
Okay.
They
Hello,
they ate themselves.
Yeah. Dean Arvidson has a question.
yeah, a nice presentation, Bill. I'm going to reveal my ignorance of some of these terms. Can you explain what hot staging is in a little more detail, what that means?
Yes, I wish I'd gone through the video, but Titan used that. If you ever look at a Titan, the interstage between the first and second stage has a bunch of holes in it. The Soviets use that even today, and especially their N1. If you look at a Soviet N1, there's all kinds of holes in the interstage, and that's to let the exhaust out. So they start the second stage engines while it's still attached to the first stage. And then the engine exhaust blasts the top of the first stage, and normally you don't care because it's expendable. But SpaceX put in some armor, some ablative shielding up there, but they hope to reuse boosters with 1 hour turnaround time. But the great advantage of starting the second stage engines while the first stage is still idling, the first stage they go down from 33 to only 3 engines. And then they start the 6 second stage engines, and the exhaust comes out these holes. And then they release the clamps, and the second stage flies away. But the great advantage of that, if you look at a normal Falcon 9 launch, it takes 3 or 4 seconds between first engine MECO, the main engine cutoff, and then they separate, and then they coast apart for a few seconds. Then they start the second stage Merlin to go on to orbit. And every second you're not thrusting costs you 32 feet per second in gravity loss. So to minimize that and to maximize efficiency, um, starting the second stage engines while you're still attached, super risky, super gutsy move. And you have to give it to them. But they made it work on the first try, and it wasn't even in their roadmap, their product roadmap for a long time. And then their original product roadmap wasn't to make these out of stainless either. They were going to make them on a mandrel. They had a 12-meter diameter mandrel. They spent millions of dollars on a fabrication site near LA Harbor to build these out of carbon fiber, 12-meter diameter. And they ended up going down to 9-meter diameter, and that's sorry, stop that. Went down to 9-meter diameter, went to stainless steel because the economic trade-offs worked really well. Stainless steel is denser, but you can make it thinner, and it's easy to fabricate, it's easy to repair, it's easy to pound dents out. On Mars, even, just carry your own welder and mallets and you can fix it. Carbon fiber is very difficult to fix in the field. Anyway.
I got it. So it saves those few seconds of time are significant enough savings to make it worth the risk.
Yeah, it's shocking, but they did the math, and Elon even said we win 2 to 3% more mass to orbit. And when people are trying to get 0.2% improvements, then a 2 to 3% is a huge gain and worth all the trouble they went through, because they had to build, they had to build a bunch of test interstages with all these holes in them, and then they have what's called a can crusher at the test site in Texas, and they had to compress it to make sure it wouldn't crinkle until well past the design strength. But when you've got a Starship fully fueled at stage separation and you're accelerating at 3 to 4 Gs, that weighs a lot. So there's a lot of pressure, a lot of force on that poor interstage where a lot of the skin is gone. So it's just stringers and stiffeners.
Thank you very much, Bill and Dean, for your questions. And Bill, please hang around. There may be more questions. I know that Ron Story has to step out, but I would sure like Ron to give us an overview of the Star Trek convention, a brief one, before we bring on Bob Solheim and Torsten. So, Bill, that was extraordinary, absolutely extraordinary. Thank you for that. So, Ron Story, are you still available to give us a little thumbnail?
Let's see, where should I start? So anyway, the Northern California Mars Society group was out there, and they had a table for us, and they had a TV monitor and a bunch of display boards and stuff, and they were running a continuous feed through the TV screen for the MDRS pictures from previous MDRS crews. And I had a PowerPoint presentation that pretty much most of the slides were from the slides that you presented to us a while back, Dr. Melton.
Mm-hmm.
And a few in current events and stuff like that. So so we got through. We handed out about almost 100 tri-folder applications, and let's see, and the mission statement handouts, and let's see, and Northern California handed out like a bunch of business cards, which I bet we probably boosted their membership to their organization by a lot. One lady was so excited, she wanted to sign up right then. So we took her to our website, and she became a member instantly right there on the website.
It's easy to do.
So she was so excited. So second topic was Dr. Zubrin showed up Saturday morning, and he started immediately signing books, and signed books until it was time for him to go into the conference room. And he had about 40 minutes for presenting. I think there was like about 500 or 600 people in the room, and he gave a pretty good speech. And he took questions afterwards. Now, one of the things I was quite impressed with was the people that came by the table afterwards. There's people from NASA, pilots, aerospace engineers, all different types of aerospace companies. And some of them we asked, would you like to learn about the Mars Society? And several of them said, I'm already a member of the Mars Society. Uh, I'm like,
Well,
oh, great.
show up at the chapter meeting then.
Yeah. So I said, well, are you local? Well, if you're local, you're sign up for North California chapter right here. And here's the leader from the chapter standing right here. Feel free to ask him any questions.
Yes, well, thank you for that little overview. I really appreciate that, Ron and Ed. My gosh, you went above and beyond. I'm not even going to ask you to talk about it, but
You don't want me to.
yeah, to pull that together and what you did, and to get Dr. Zubrin there to speak and to make it all fall together. You and Ron were, I can't think of a better couple, a team to go out there and represent us. And I'm so pleased that Scott Davis was in attendance also, and that we did support him with some members. I would suspect that that would occur. So my thanks and the thanks to the Mars Society for both of you going out there to do that. Because who knows where people hear about these things, which is a very fine segue to Bob. Bob Solheim. And Bob, where are you located again?
I'm located right now in Chandler, Arizona, but I also have a house in
Okay.
Simi Valley, California.
All right. Well, I know I've asked you to give us just a brief overview of how you became interested, and Bob is our newest ambassador. We've been bringing people on board regularly, and Bob and I chatted last week, and he is our newest ambassador. So welcome aboard, Bob. Give
Thank
us
you.
give us an overview of you yourself, what you do and what you've done, and just a thumbnail of that. That would be helpful.
I've been interested in space ever since I was a kid. For some reason, I just saw what was going on in space and said, this is something I want to be part of. I can remember in junior high, I built rockets and sent them up. In high school, I built rockets and sent them up. In college, I built rockets and sent them up. And really learned a lot from that. I've got a bachelor's degree in physics from ASU and master's in business administration from Arizona State also. As far as my work history, I am retired from project management. I've worked with rocket engines, advanced technology, and those sorts of things at Rocketdyne in the San Fernando Valley for about 15 years. That was a latter part of my career. But overall in aerospace, I spent about 27 years, and that was all in Southern California. As far as my recent involvement in space, rocket engines, and STEM, since my retirement about 13 years ago, I guess now, I've made presentations of space, rocket engines, in STEM at high schools, junior highs, and elementary schools. And I really get excited when the kids get excited. And I show them things that they had no idea of about those subjects. And I've given those presentations in schools in California. I've given them in Arizona here and also in Washington State. So that's kind of a quick recap of my background. I'm honored to be part of the society, and I look forward to being a contributing member of the society. I want to make everybody aware that Arizona is having a space summit in 2 weeks at the ASU campus. And the first day is going to be in the afternoon, a job fair for students that are interested in aerospace. In the evening of that first night, there's going to be a meet and greet. And then the next day, they'll get down to brass tacks and they'll look at things like development in LEO access, how Arizona can be involved more with space economics and those subjects. And they're looking to try and increase their involvement in the space initiative. So the second day, they say the governor from our state is going to be there to hopefully speak for a short time, which would be interesting. And if you have any interest in that, just get in touch with me. I'd be glad to send you the invitation I got when I found out about it. Like I said, it's on the Arizona State campus in Tempe, and that will be March 27th and March 28th.
Excellent, excellent. Thanks for bringing that on board. I appreciate that. And we are proud to have you on board, very much so. And one of the things I think that prompted you to come on board is because I was not sending you invitations to the ambassador briefings anymore, which was purposefully done because, as I said, we were getting a lot of participation from people who were really not that familiar and getting down to a lot of basics. And we thought, well, this might be a good idea to have a closed program, at least for a while. And Bob wrote me and said, I haven't received an invitation for a long time. What's going on? So I said, well, why don't you become an ambassador? And he jumped on board. So that's good. So very good. So before we take any more time, I want to thank you again, Bob. And
Sure.
I want to bring Torsten on board here because you said, Bob, that there's going to be a conference coming up in Arizona, but Torsten, one of Ambassador Eschweiler here, is going to be speaking. I believe it's at the Analog Astronaut Convention. And Torsten, if you would be so kind, give us a little insight as to how you got that particular speaking engagement and what you're planning to share there, and any other bits of information that you can help us so that other people will get an idea as to what they can do to do what you're doing.
Yeah, so can everyone hear me?
Yes.
Awesome. That's the most important question. I've been to the Analog Astronaut Conference last year already, and I spoke about the same topic, but it was more like an introduction. That's how I got involved with the Analog Astronaut community, and I see analog missions as the vital step for us to become a multiplanetary species. And for pretty much a testing ground for all kinds of technologies and how we can live sustainably and so on. So my topic I speak about is, so last year I spoke only about the audiovisual entrainment technology, providing potential clinical and physiological mechanisms for space environment. This year's presentation is building upon it. So now I include the cranial elective stimulation component, CES, pretty much acting in synergy with audiovisual entrainment technology to boost human factors in space operations. I think it's pretty much important, especially for analog habitats in isolated, confined, and extreme environments, and to see if it can, pretty much boost human factors, just introduce relaxation, decrease stress, optimize performance, pretty much improve overall well-being, mental health, and sleep. So, I'm not sure if you know what audiovisual entrainment is. Has anyone heard of it, the term, or about the technology?
Go ahead, John. Did you have a comment?
No,
John?
I'm not familiar with it either.
Okay. The only thing I'm familiar with is the toning. And for instance, earth tones like 7.83 hertz is
Yeah.
Does it have anything to do with something like that?
Yeah, so it's actually a pretty complicated topic. I have to give you a quick rundown of it. So what it's doing is so it's pretty much a light component and tone component. So light is pretty much undergoing a stroboscopic effect, and we can break up tones into pulses. So basically, it's an eye set with pulses of light and a headset with sounds at specific frequencies that gently and safely guide the neural networks of the brain into various brainwave patterns or neural oscillations. And the research I'm focusing on is this device. So it's pretty much a portable handheld device. It's from a company called Mind Alive. And I can show Mind Alive. It's a Canadian company. It's an award-winning company for neuroentrainment, neuroenhancement stuff. It's well known actually in the field of neurology. Let's see here. This are the glasses, and then we have headphones as well, but we can use any kind of headphones. But the most important thing are these glasses. So we wear these, and what these are doing, I hope you can see it. I have to increase the intensity a bit. So what's it pretty much doing? Sorry about that. I'm losing my head. So what's it doing is pretty much flashes of light. And the beauty and the unique capability of the Mind Alive devices, you guys can see pretty much 2 flashes of light in each eye.
Mm-hmm.
So it means every left field of each eye goes to the right hemisphere, and every right visual field of each eye goes to the left hemisphere. So we can pretty much stimulate both hemispheres separately. Why is it important? It turns out when we have neurological illnesses like or disorders like ADD, ADHD, PTSD, migraine, the list goes on and on, that one part of the prefrontal cortex is shut down or has a higher activity. For example, the state of depression means one of the sides of the brain is shut down and the other one is too active. If the side that's too active is the side that tells you to stay away from people, you have a depression. So the question is, if we apply this technology, and it has been proven in the past, it can alleviate depression symptoms very rapidly and very efficiently. It's pretty much balancing the brainwave patterns out and brings it back to normal. So what's it doing is pretty much it reboots the brain again. And the question is, this is actually a good approach for all kinds of stuff actually. If it works here on Earth, we can use it in space as well. But the question is, does it work in space? How does microgravity affect neural oscillations or brainwave patterns? Or even when we go to Mars, how does it affect our brain and brainwave patterns? The thing which you mentioned, James, is the 7.8 hertz, the Schumann resonance frequency of the Earth.
Yes.
That's pretty interesting because what this device is doing, it also increases cerebral blood flow. And the peak of cerebral blood flow seems to be at 7.8 hertz. And that's the interesting thing. It's like, is there a correlation between the Schumann resonance frequency and the peak of cerebral blood flow in the brain? If so, that would mean we have a problem when we go to space, to the moon and Mars, because Mars has a different Schumann resonance frequency.
Mars is a different personality.
Yeah, could be. That would be interesting as well, because this audiovisual entrainment device can be used for behavior disorders as well. I've seen so many talks about therapists talking about turning a grumpy people or grumpy husband into a happy one in a quick amount of time. It's like, how does it do that? why is it happening? It's actually a treatment for TBI, traumatic brain injuries as well,
All right.
concussion. But the problem with concussions is, and that's the scary part I read recently, a concussion is pretty much a signal of loss of signal transmission in the brain. It can happen when we had a crash as a kid, or when you bump your head, or some kind of negative experience, traumatic experience. Even watching television now, watching the news, can pretty much give people concussion.
I can't imagine that with all the good things on TV going on right now.
Yeah, exactly. I wonder what that does to people and the mental health and even the
Yes.
brainwave pattern.
Yes.
That's pretty scary.
Yes. So to sum it up, would you say that the vibratory tones, the resonance that you create with this instrument and the glasses would be a health benefit in all areas? And can you isolate those to specific areas?
Depends on how you define all areas, but I see it definitely as a health benefit for most areas, especially nowadays for mental health issues. I think this approach is actually a solution to the homelessness problem in the United States as well and elsewhere, because there's a big mental component. I mean, we all have mental components nowadays. Everything affects us differently.
Yes. Yes.
And it's not the holy grail, but it's very, very effective. And it's more like a niche product. The thing why it's not more widespread because of the pharmaceutical industry, because of power and profit. And it's a little bit stigmatized from the 80s and 90s when we had the esoteric movement using this device or these kind of devices which were more clunky and not sophisticated enough. We didn't
The
know
biofeedback, etc.
Yeah, it was really messy in the 90s. No one knew how it worked. Esoteric society was using it for spiritual awakenings, out-of-body experiences, lucid dreaming. They misuse it for all kinds of stuff. And it's kind of stigmatized from that. And there are a lot of companies that are building these kind of devices. And it's not only that you have flashes of light and pulses of tone. You have to apply it in a way how the brain works.
Well, this is a new dimension to a lot of people.
Yeah.
And I'm sure that you will include the Mars Society in your presentation in some way, that we do explore and encourage exploration in new areas at all times. Leaving it up to the individual, of course, to make their own choices. And you had one other thought there?
Yeah, it's all about the frequencies, like delta waves, because everyone that goes to sleep has delta wave activity. And that's another thing. If people have insomnia, they cannot sleep, they lack delta wave signals in EEG. Using audiovisual entrainment, for example, this device, we can see in EEG that the delta wave activity comes back and it stays. It's nothing that the drugs can do.
Yes.
So that's interesting. And there's recent research on gamma frequency. The latest version of the device by Mind Alive has gamma frequency as well. And it seems that gamma frequency is a treatment for Alzheimer's, dementia, and even cancer. So we don't know what's going on there, but it seems very promising in this area.
Well, thank you for the overview, Torsten.
Well, that was a quick rundown. There's much more to
Very
talk about.
quick. Yes, there's a lot of body in what you have to share. And it's an area that has been explored for quite a while, but we're getting a lot more targeted with our the resonance tones and what can be done. So I appreciate that. I'd like to hear more about that after your talk and how it was received and what other insights may have surfaced during your program. So, but thank you today. I really appreciate it. Does anyone have any questions for either John? Go ahead.
Yeah, regarding the resonance frequencies, is that something that can be facilitated with some of these new virtual reality goggles? And secondly, is the resonance frequency associated with Earth's magnetism or something along those lines? And how different might that be for Mars?
Yeah, with the VR integration, we have to see if it's a good fit or not. But it has nothing to do with VR right now. It's pretty much only an entrainment. But maybe there's an integration possibility there. With the magnetic field, that's a good question, actually. I haven't read any studies about that, but that would be an area to explore. Especially with the Schumann resonance frequency of 7.8 Hertz. This really fascinates me. If there's really a connection, we have a problem on Mars, to be honest.
Yeah, every organism, every body, every biological structure has its own vibration, and that's I actually use the 7.8 for A3 for meditation in my life, and I enjoy that. It's very comforting for maybe 7 or 8 minutes a day, and it's interesting. And you can look that up on the internet, of course, if you want to. Or want to talk more about it, just connect with either Torsten or myself. Does anyone else have any questions, say for Bill, for Bob, for Torsten here, and or for Ed Hessler, who's joined us, who was at the Star Trek convention? Any thoughts, comments? Alita, are you out there, Alita?
Yes, sir.
I haven't heard from you for a while. Just say hi to our family of ambassadors, Alita. And are you in Florida now?
Yes, I am. I recently was in the Life on Mars simulation, so I was a bit busy with that, and then I was busy with classes. And I also got another analog mission in May, so I'm like using my dissertation as the project for that analog. So I'm just working on all of that, which is why I missed some of the meetings, but I kept watching the recordings.
Wonderful.
And,
go ahead.
oh, no, I was saying it's really such a pleasure to hear everyone speak, and it's been a long time.
Yes. Well, we've missed you, but I knew you were out there doing good stuff. I promised I would provide a segment on deuterium, and many of you have commented on that. So let me slip that in right here, and we can talk about the details later. I watched the movie Oppenheimer, and they talk about deuterium in the movie. And many years ago, I watched an atomic bomb blast at White Sands, New Mexico. That's something you don't want to mess around with. Now, deuterium is necessary for nuclear power. A side note is it's 5 times more prolific on Mars than it is on Earth. Deuterium is a stable isotope of hydrogen, but it has twice the mass of a standard isotope. So it's needed for fueling fusion reactors. But in today's world, we don't have any fusion reactors, at least working fusion reactors. They are working on it, and we've been working on it since the 1940s. So when will we have a working fusion reactor? Well, estimates are that we'll probably have one 20, maybe 30 years from now. But with the advent of the Mars Technology Institute, that may come a lot sooner. We're counting on it. Let me give you some stats here. A deuterium helium-3 reaction provides the best energy performance because the fuel has the highest energy to mass ratio of any substance found in nature. So by using pure deuterium, in a rocket, we could reach 4% of light speed. And by using a deuterium helium-3 fuel, we could reach 6% of light speed. So fusion propulsion could ultimately make travel to Mars so much easier and probably do it in weeks rather than months. So our bottom line basically is to generate a clean, reliable, self-sustaining energy source. And I think the Mars Technology Institute is on track to make that happen. We're counting on it. Stay tuned. I was very enthralled with all of your presentations today, and your participation is so valuable, and we look forward to you continuing to be involved and sharing your knowledge with the world. I mean, that's what we're all about as Mars Society ambassadors. So this is James Melton, Chief Ambassador to the Mars Society, signing off. On to Mars.